we have steering. Well, at least one side. Now I know the disappointment you open differential guys have. What is going on, guys? Welcome back to the Ovenged channel. And as you can see, we got steering on one side of our buggy. I went ahead and I made a tie rod assembly, as you can see, tacked in a few tabs on our spindle, and well, we have steering on one side. Now, before we dive into this, I want to go into a little bit in depth on geometry, on suspension setup. I kind of want to explain to you why we've done it this way. And if you're watching this, whether it be now, whether it be in the future, whether you stumble across this build and you're kind of wondering if you're going to do your own build and you're going to be like, well, geez, that guy had a bunch of headache designing his front suspension. Well, this isn't typically what you're going to do. So I want to dive into it a little bit, and I don't want you to get discouraged by watching me struggle with this. So first and foremost, what we're going to do, we're going to put this CAD diagram up on the screen here, and I want you to take a few key notes on how this thing is set up. The first and foremost thing I want you to notice is that our CV axle along with our tie rod assembly run parallel to each other. If you want to look inboard towards the chassis of this vehicle, you can also see that our pivot points are right around the same area. If you come out towards our spindle, towards your steering knuckle, you're going to see that that heim joint, along with the lower control arm uniball mounting point, along with that outer CV joint, which we can't really see here, that's all right around the same plane. So that's going to keep the geometry pretty simple on this build. I don't want to put that in layman's terms. This was definitely a crazy build by whoever done it. But just to keep it simple for essentially what we're doing here, so I can explain how I done my machine and how they done theirs on this CAD file. We're not going to get into angles. We're not going to get into certain specificalities of this thing. I want you to kind of key in on certain aspects there. That way I can kind of show you the differences between the way I done my front suspension and the way this is kind of done. But with that being said as well, this probably has like a $15,000 shock on it. So it's kind of apples to oranges, but this kind of shows the geometry the way that it should be done when you're doing. Now I'm throwing around the word geometry like I wasn't pipped off in geometry class riding mountain bikes out in the hills with my friends while the geometry teacher was explaining what geometry is. Sorry, Mom. Now I also want to point out, even in that CAD photo that we just looked at, that was a factory truck at one point, whether it's a Toyota, Ford, Dodge, anything that had independent front suspension with upper lower control arms, along with a CV axle to make a four-wheel drive. Essentially, everything is blueprinted and hard parts have their designated area that they live in. Essentially, with that truck, you could see that, well, your steering rack was in front of your front differential. Everything's on the same plane. And even if you're making a four-wheel drive tube chassis buggy, you know that you have a certain amount of real estate in front that you're going to have to put your front differential and you're going to have to put your steering rack. It just makes it easy. And usually it's right on the bottom of your tube chassis, so everything's on the same plane. Once again, you don't put parts on top of other parts that is going to have moving outward parts. Which brings me to this. So now that we're down here, you're probably noticing where it's kind of different from that picture. Right off the bat, you're probably thinking, well, Mitch, you just preached to the choir to us that you don't put hard parts on top of other hard parts if you want to maintain proper geometry. Well, right off the bat, I went ahead and I put our steering rack on top of our CV axle. And as you can see, the mounting point is actually in here where our CV axle pivots back here. So that creates its own world of problems. Now, if you look out further, you can see that this lays kind of flatter, it doesn't run parallel, and it's kind of higher up on our spindle. Ideally, you want this to run parallel, and you want your outer heim or your outer ball joint to mount generally in this location right here. That's just, once again, proper geometry. But if I were to mount this in this location and mount my outer tie rod end link, whether that be a heim, whether that be a ball joint, down here, then this tie rod would have to be substantially longer, probably an inch and a half longer. And by doing that, when you come up through your suspension stroke, well, what's that going to want to do? This is actually going to get longer from here to this point, and it's going to want to shove out on the front of your tire, in front of your spindle, shoving your tire out. That's how you get bump steer. Now, if it was shorter, of course, once it goes through its travel, it's going to want to haul this front tire in, once again, bump steer. And that's what we're trying to get away from here. Now, you might be saying, well, why did you do it this way? Why did you go ahead and put your steering rack up here above all this? Well, there's a couple key things that we have to take into account here with this thing. This was never meant to have any suspension whatsoever. Like, this had zero suspension. This had tire, essentially this tire was in here. It was just a straight axle out to this, or a straight stub, steering stub. It kind of creates its own world of challenges with doing something that's not supposed to be done. Now, on the other side, the big red flag in the room is that I want this amphibious. I want this to stay amphibious, so there's certain points that had to stay exactly where they're to. There's certain seal faces, there's certain tolerances that I have to maintain because we got certain bearings and seals in certain places. And once again, we want amphibious capabilities. Now, I could have came here with the steering rack and kind of shoved it down here, and at least then I would have been able to lay it a little bit flatter, and we could have mounted it right here where it was supposed to be. By moving this down here, I would then be in conflict with the inside of the tub and our chassis and where this axle or our drive axle runs inside of our tub. So that wouldn't have been any good. We would have been kind of hitting each other. And by doing this as well, I would then have to build out my frame out here, probably whatever, 3, 4, 5 inches, out here a bit further, and then that puts my main frame here of our tub before our tires. Now I want the tires to be the first thing it hits, whether it's a bank, whether it's rocks. I don't want it to hit here. So if I were to put this down here, if I could have, then that would have been the first thing in our harm's way every time. The first thing you're going to hit is going to be down here, and that's going to be your steering rack, and that's going to cause its own world of hurt. So with all that being said, that's why that's like that. Now we also have to realize this isn't a pre-runner buggy. I'm not doing 100 miles an hour through Paris to Dakar. This is essentially just an off-road buggy that we're going to be using on kind of woods roads, marshland, probably in water if it floats. And the way this is set up now, even though it doesn't look proper in proper geometry, it works similarly. It works similarly. It has similar characteristics to what you want in a suspension. I was probably playing guitar during English class or something, maybe. Sorry, ma'am. And what I mean by that is that we don't have any bumps there. Essentially, we don't have as much travel as whatever that thing is there in that CAD photo. I don't want to go out and spend $15,000 on a shock so I can get that amount of travel out of it. I don't want to go spend another $3,000 or $4,000 on high articulation CV axles. For what we're trying to achieve, this is going to work. There's no bumps there through our suspension travel that we have with this buggy. And we're just going to send it like this. Now, with all that being said, you're probably thinking, well, Mitch, what happens when this is kind of fully compressed? That's fully drooped out. You're in a spot, you're going slow. How's it going to react? Like, subscribe, hit the bell notification, and we'll find out together, I guess. So to touch on something else, I've always wanted hydro steer on this thing. So if this steering rack ever gives any issue whatsoever, plan C, I guess, because plan A was factory, plan B is this, plan C would be hydro steer. We're going to go with hydro steer somehow, but if this works up to whatever way I want it to work and it doesn't give any issues, for the price of it, once again, budget, price standpoint, this is the cheapest way to go. So if this works, why mess with it? So what we have, guys, we went over on the horizontal bandsaw, cut off a piece of pipe. This is actually 3/4 ID, which equates to around 1/1/16 OD, which is outside diameter. I went ahead and cut it at 18 inches long, and I put this piece in here. Now, I actually turned this down on the lathe, which is about 3/4 OD to slip inside. So this way I'll have a nice little seam right here to weld along with another plug weld. So we got to make this other end. So that's what we're going to do on the lathe right now. So might as well go ahead and hit it. So this right here, guys, this is what we made on the lathe, this little tiny insert. You may be thinking, well, how'd you know what size hole to drill? Well, if we come in here on our steering rack that we bought off Slamazon, there is a jam nut. And this is the longest threads I've ever dealt with in my life. This is the jam nut. So if I bring you over here, this is a thread checker. You can also buy these off Amazon. So all you have to do, take your nut, and even if you have a bolt, it has different options for that as well. But if you got a nut, you just kind of match up where it goes. So this one here fits on M10 by 1.25. Now a quick Google search tells me that the proper drill bit size, which is this hole here, is 11/32. So now we just got to go over and tap this and insert it into our tie rod. Like a glove. Like a glove. Now I'm missing a jam nut here. I kind of have to track one down, but for mock-up purposes, I think we'll be okay. It's just a little loose in those threads, but the jam nut will take those up. Now, are you guys sure you can get up out of this, or you're kind of getting old, I can see, so you need a hand up? All right, I got you. So guys, we've got steering. Essentially, I've went ahead, burnt out a couple more tabs for this side knuckle, and yeah, we've got steering right now. So I went ahead as well and hard mounted our seat. I've done a little bit of cutting, a little bit of bendy, and we have our seat hard mounted now. As you can see, it's pretty cool because we have adjustment. If someone, you know, shorter wants to drive this thing for whatever reason, you'd want to drive this thing if you were shorter. I don't know. Now, if you want to look a little bit closer here, we also have our hard line, which is our brake line, ran from the front right to the back. Preliminary, just in place, loosely put in place, but that's essentially, it's going to be its home. We also have our throttle cable ran from our engine up to the front as well. Now, if I can get you a little bit closer, let's explain the brakes. Now, I want to explain the brakes to you guys because essentially the way the brakes were set up on this thing was we had just kind of like a cantilever set up. It was a hard piece of brown stock that ran the full length of the tub, and we had this kind of cantilever type setup for our brake caliper. Now I'm going to kind of get away from that. I'm going to run this hydraulic setup with our master cylinder and brake fluid, and we're going to mount that somewhere here. Now, as you can see, we already have our rubber line already ran, but this is going to allow me to put this somewhere like that. I'm coming with a really nice bracket for our caliper bracket. But in turn, I can hopefully integrate a bracket for this rear motor mount as well. And I can get rid of this 1x1 tubing, which was essentially just there to hold everything together for mock-up purposes. Anyway, essentially this is how you shift your gearbox. We have a high, low, reverse, and 2 neutrals. And that just pulls out on this shaft and locks it in the gear. Now this gearbox has straight cut gears, so we got to be kind of careful when we're putting this in that gear because we don't want to round out the edges of our gears, but that's in another video. So if we're going to walk up to the front of the machine here now and check out our front brake system, well, I went ahead and installed our master cylinder out of our UTV donor. Now, as you can see, it worked out great because this comes up here. This is, once again, all out of that donor UTV. Mounts perfect here, and that's kind of its home. That's where I want that to stay. Now, I went and burned a bit of 3/16 plate for the mount, but I still want to come in here and gusset it a little bit because, you know, you get into those moments where you really put your foot into the brake when you're in sketchy situations. But this is going to come here, and I'm going to make a nice mount for that and tie all that together. So I'm happy with how that works. Now, previously I said I was going to try to just run back brakes. So essentially the brake system will lock that gearbox. The gearbox locks the back axle locks your sprocket, sprocket to chain, chain to sprocket, sprocket to front axle, and that's how you get 4-wheel lockup in this thing. Now that may have been fine for an 18 horsepower Tecumseh motor where you could probably only do, I don't know, 20 or 30. We have around 85 to 90 horsepower now, and who knows what the future holds here with this thing. I mean, I may want to put tracks. It's at least getting bigger tires. I mean, we may as well face it. It's going to get different tires than this. But if you're ever in a situation where the chain breaks and you're coming down a steep hill without any front brakes or anything like that, you're kind of going to be at the mercy of the hill, and it kind of gets unsafe very quickly. So that's why I've made the executive decision to actually just go ahead and put front brakes on this thing. I've been throwing it around ever since I was building it, if I was just going to kind of work with the back brake system, see if that was sufficient enough for what we were trying to achieve. But seeing that we had that donor UTV, it's already plumbed for it, as you can see here, and this is the front brake system off that donor UTV. It kind of falls into place. Now, I'm going to do the front brakes a little bit different. Instead of coming down here and putting them out here in the hub assembly, which you would see on like 98% of cars, I'm actually going to turn around and put them in here, which I believe is on some maybe Renegades or something like that. I mean, I already have the disc, I already have the brake caliper. As you can see right here, we also have sufficient amount of brake line. And I already went ahead and made this bolting flange to accept our CV axles to our drive axle. So if I got to drill a few more holes in this thing and make a nice caliper bracket come off here, it should be pretty simple, essentially. I say essentially because I've never got into that before. But everything's there to make it work, so I may as well just do it and stop crying about it and get it done. So I think that's going to be pretty cool. It'd be cool to have front brakes on this thing along with back brakes, and that's what we're going to do. So what we're going to dive into now, I want to get my foot control set up in this thing, you know, brake and throttle. So let's just jump over to the plasma table and let that thing cut. So these right here, guys, this is out of our donor UTV, these two pedals here, and this is what actually controlled our Terra jet. Essentially, that's set like that. We had a solid round bar that went back to the carburetor on your Tecumseh or whatever it was on these things. But we're not going to use that. Get out of the way. I've come up with these. Now, I've actually grabbed this file and modified it. These are actually on the website FireShare. Now, if you get into the Langmuir system, whether you get into the CNC plasma tables or their mills, you get access to what's called FireShare. I'm not sure if it's an open source thing where anyone can go check it out, but if you have a table and stuff anyways, you can sign up for it. So a guy actually designed these for a racing simulator, and I kind of tweaked them and made them work for our application here, but it looks miles and miles better than what came out of it. And this actually worked out in my favor a little bit, because if you remember correctly, I had this hole here for our original factory steering setup. This is where our bushing and our seal face kind of set, and when a rod came in and out, and that's how we sealed our tub, of course. So what I'm actually going to do, I'm actually going to get a rod, because I had to seal these anyways, kind of put in through here, and in turn, that rod will slide through here, and that's how we're going to have that mounted. So let's dive into it. Come up with these two tabs, guys, and what this is going to allow me to do is kind of seal those holes inside of the tub. This may seem a little bit janky or weird, I'm not really sure, but it's actually a Sunday here, and I can't go anywhere to get any round stock, but I have had this kicking around for quite a while, and it's just an old breaker bar. Now, realistically, this should be some sort of hardened steel along with this coating. So I think I'm going to use this for the main pivot point for our pedals. So it's kind of going to go like this. I'm going to weld one here. It's going to slide through our tub. Then it's going to get welded solid and welded solid on the other side. And that'll seal the tub, seal the tub. And then what I'll do in the future, when I get my pedal positioning left to right, the proper distance or in the proper location, I'll just come in here and make a couple C-clips and just weld them into place. It's going to suck if we ever have to take that apart again, but I'm hoping we'll never have to take it apart again. Hopefully. So there we have it, guys. That's kind of what I had envisioned. Now I have to weld that inside and out. That'll keep us sealed. Once again, we're doing all this because we have to keep it sealed from the outside, because we want, you know, to be able to float. So this is how I kind of had everything set up. As you can see, we got brakes now. That's going to be perfect. I may have to lose this bar for the simple fact that I have size 13 sneakers, and when I'm kind of pivoting here, sometimes my sneakers actually kind of, the tip of my toe kind of hit that bar, but we'll work around that. As for this, as you can see, this is going to be our throttle cable, or a throttle pedal I should say. I'm going to have to come up with some sort of stop for this, and probably a little tab or an ear to come off the side here. Just kind of put it out of harm's way. It'd be nice if I kind of had it around this same plane as the brake, make it a little more comfortable. With that being said, I think we're going to call that a day on that, but we put a pretty good push on that one, I must say. There's one other thing that I want to show you guys that I've been throwing around the idea with, and I'm not sure if I'm really happy with it yet. So let's talk about fueling. I have this plastic tank out of the UTV. It's a pretty nice little gas tank. It would work perfectly. Of course, I would cut this bracket out and mount it down pretty much flush, lower. I could then come in and make like a nice piece of aluminum shaped protection bracket thing around it, I guess, cover. And we could be done. We could be done with that. We could plumb that in. The engine itself has its own fuel pump, so we could just kind of block all this off. But I don't know if I like it. I'm still up in the air about it, because the thing about it, well, one, we have a gas tank right next to our arm, and two, I'm adding a lot of weight behind the center point. So like from a weight distribution point, I kind of want the tank up here just to get a bit more weight over the front wheels of this thing. Now, there is going to be a little bit of weight because I'm going to put a battery here, but I mean, what's that? Probably 8 pounds, if that. So it would probably be nicer if I came in here with a piece of aluminum, made a nice tank, kind of come up, but that's a lot more fabrication, it's a lot more money, it's a lot more time consuming. So what's your guys' opinion? Should I just run the plastic tank and be done with it? And it's a nice little plastic tank. I mean, I can kind of cover it up with a nice aluminum cover, like I said. Or for weight distribution purposes, should I put something up front? Now, I do plan on making a bumper with a winch. That's going to give a little bit of weight to the front, but I mean, if I'm 230 pounds, 220 pounds, and this is 50 pounds, let's just say hypothetically, all that's a couple hundred pounds back here. I don't know. I think it's probably a little bit too much. Of course, like I said, I would mount that a little bit lower. I could even shove it up here if I wanted to get a little bit of weight on this side of the center point. I don't know. I want your guys' opinion on that. I do. Comment down below what you think on that one. But with all that being said, guys, I think we had a good push in today's video. We're getting closer. We're getting closer to get this thing up, running, and moving. On the next video, we're going to finalize our braking system. We're going to get that bracket done. We're going to make sure that that engine is hard mounted in. Hopefully I can figure out my steering. I'm going to do a bunch of research on my steering to make sure that that's as solid as it can be. I don't want a janky steering in this thing. Then I'm not sure if we're going to probably do like a roll cage because I need to get plumbing because that is a liquid cooled motor. But we're moving along. I mean, realistically, if you wanted to kind of make a makeshift fuel system on this thing, you could probably just start it and move it right now if you wanted to, but I kind of want to finalize it, even if it is a mock-up phase. You know, I kind of want to make sure that it's safe and it's working properly and we can build off that foundation as opposed to just rigging stuff up. But with all that being said, thanks for watching again, guys. Next video, like you say, will probably be brakes on this thing. But give us a like, subscribe, hit the bell notification. I hugely appreciate it. I'll see you on the next one.